Okay, we're going to cover how to use a dial bore gauge today, and not only how to use this, but also how you can use it to measure cylinder out of round, cylinder taper, and measure a few different things. So first thing is, this is kind of I wouldn't say very complicated, but it's a little bit tricky to learn to use this. So there's a few things we should check out first. The first thing is, if you watch my hand here, as I squeeze this, note that it's moving this gauge just like a dial indicator. The next thing is, if we zoom right in on the screen, you'll notice it says 0.0005. Each one of these lines, these small little lines here, I'm trying to move just one, it's very difficult. Each one of those lines is actually a half of a thousandth. So a full thousandth is going to be like the movement of two lines. So it's so small I can barely even try to move like 3 or 4 lines, but just know each line is half a thousandth. The other thing to point out is this small little circle gauge here. Note that as I move, as it goes a full lap, it crosses 1. If I do another one, it'll cross 2. And so that helps you make sure that you're pointing to, the right numbers, and you're not thinking, oh, okay, well, it's 0, but in reality, it's actually gone a full loop around. It's not really at 0 anymore. That's kind of like 0 plus a full rotation. And so just a little bit of that makes sense. The next thing is, if you're starting kind of at 0 here, the focus is, as the needle goes this way, like this, the more it turns that way, the smaller the hole is. And the more it turns this way, towards the green, the larger the hole is. And so smaller, larger, and you can kind of tell because plus is kind of larger and then minus is kind of smaller. So that's just overall kind of how this thing works. The next thing is, you need to set it up to measure a specific cylinder. This cylinder was originally made to be a 4-inch bore, but it's been machined. Several of these have been machined, so they end up somewhere between 30 thousandths and 50 thousandths over. So if you want to know kind of your cylinder size, sometimes what helps is either look it up, and they have varying different lengths of adapters, and you can do some fine-tuning adjustment on these to kind of get it in range. And so go ahead and look it up, and you can put in the right adapter. But what I do is a little bit different. What I will do is I'll take a telescoping gauge just as a quick down and dirty measurement, and I'll go ahead in there and I'll expand it, and I'll make sure I try to get it nice and square in the cylinder. And then from there, I'll go ahead and I'll measure that with my micrometer, and I'll pretty much know what I've got here. And so because I did a down and dirty measurement, I know that my baseline is going to be 4 inches and about 50 thousandths. So from there, if I know kind of my baseline, and it should be easier for you if your block has never been machined. You would just be like, oh, it's a 350, it's 4-inch bore. I'm just going to set it up for 4 inches. What we're going to want to do is we're going to want to take a micrometer, and in my case, I set it to 4 inches and 50 thousandths, as you can see here. I'm exactly at 4 inches and 50 thousandths. Now, this isn't how to measure using a micrometer. I'm assuming that you know that. But from that point, what I really want to do is I need to lay this dial bore gauge out, and it's kind of tricky. It's really hard to hold, but I'm going to basically put the micrometer on there, and I'm going to get that needle to read 0 with this set at 4 inches and 50 thousandths. So right there is my baseline. So you can see that okay, and as that's just me moving. It's hard to hold it really still. And so what that means is, if I put this in a cylinder and it comes around to exactly that 0 right there, with the small little dial behind it indicating 0, that's where we set it. If I'm right at that 0, I know that that diameter is 4 inches and 50 thousandths, because that's what I set my micrometer to. Now, when I go in like this, and I'm going to go, in this case, I'm going to go to cylinder 4, and cylinder 4 for me is right here. What I'm going to do is this little sweeping motion, as you can see. And basically what I'm doing is I'm watching that needle, and I'm trying to get that needle as far negative as I can. And so in this case, I'm going right around, it's a little over, it's like really 5.5 thousandths, but I'm going to use 5 just to keep simple math here. So we'll say that's 5 thousandths of an inch. You'll notice the further I sweep, it goes kind of back down towards the bigger hole side. Now the reason we're doing that, I've drawn here, we put this in, we're going to start with a sweep. And the more we tip it out of being perfectly square, this line gets longer and longer. So it shows on this dial indicator more and more towards the green, which is the larger side, right? So when you start in, it starts way over here. And as you're sweeping it, it gets tighter and tighter, smaller and smaller, right? Because look at this. As I start sweeping it like this line is a little bit shorter. The shortest the line will ever get is at the true 90, the true perpendicular. That's our real measurement. Now once I pass that, you'll notice it starts to get longer and longer again. So let's see really what that looks like. So if I'm in here and I start to do my sweep, this is showing a really, really big hole. It's getting smaller, 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 and then it starts to get larger again. Smaller, 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 larger again. So we're just looking for that smallest spot. And again, for simple math, because we're not going to try to crunch 0.5 thousandths, let's say we've got 5 thousandths of an inch. Now, the measurement that I just did, this is in the axial direction. So over here I've got cylinder 4 drawn. The axial direction is along with the crankshaft. So I've made that my A dimension. This is my A measurement. It's axial. I've made a little chart here. And we just measured the top of the cylinder, and I'm getting what I consider a negative 5 thousandths of an inch. Now, why it's negative, again, if you look here and you remember, we were right around there, right? And that's on the negative side. So what negative means very simply is it's a smaller hole. If it's negative, it's a smaller hole. How much smaller? 5 thousandths smaller. So if we have a base setting to our 0 at 4.050, 0 really means 4 inches and 50 thousandths. So we start with 4 inches and 50 thousandths. We then subtract what our dial bore gauge indicated. So the dial bore gauge indicated, no, you're 5 thousandths tighter than the 0. So we do 4 and 50 thousandths minus 5 thousandths, and we would get 4 inches and 45 thousandths. So that's the actual diameter in the axial direction at the top of that cylinder. So what we would do next, and once we set this, it's set for all of our cylinders, assuming they're about the same. What we would do next is, again, we could go back in that same cylinder, but this time, tell you what, I'll face it upward. But this time, I'm going to go in the thrust direction. So note, here it comes around and around and around. You know what? And that one actually looks like we show a 6 thousandths on that. Interesting. Can you see the 6 thousandths there? It's not 5. That's right at a solid 6, which is interesting. I was anticipating 5. So if we have 6 thousandths on that measurement, remember B being the thrust measurement, it's more like the way that the rod is going to move when it's going up and down. If we have 5 thousandths in A and 6 thousandths in B, what that tells us, a difference between A and B means, this is cartoon exaggeration, but we have a cylinder that was more like, let's say 5 on A and 6 on B. It's out of round. This cylinder is currently out of round. Now, how out of round is allowable, that depends on your specified service information, but the idea is the same. Technically, based on our measurement, this cylinder is slightly larger in this thrust direction. So this just told us that. Now, the next thing that we're going to do, we're going to do top, middle, bottom, but I'm actually going to run through them pretty quick. So I'm going to again start in the axial, right? I'm going to go right down to about the middle of the cylinder. I can sweep pretty quickly now, and I'm showing, I'm probably showing like pretty much a 6 on that. And so I'm going to say, and again, it's a minus, so that's a minus 6 thousandths. Okay, and now we're going to go again in that thrust direction at the middle. I'll face it upwards here. So we'll go ahead, and we're at, you know, I really only see 5.5 thousandths there. I'm going to call that another 5 thousandths. We're purposely going to make this one a little bit all over the place in the interest of math. Now we're going to go ahead to the bottom. I'm going to go in the axial direction. Now typically the bottom of the cylinder is known to be a lot of times the tightest, but this one was bored. This one's definitely at 5. And in thrust. Yeah, that one's right there really at 5 too. And so, and I did round down a little. I did see that. So what we could say is there's a bit of out around here at the top, a bit of out around at the middle, and really it's actually really round at the bottom. And so I'm going to change something just to demonstrate what this could have been. Let's just say that we got these lower numbers here at 3s, okay? Let's say we got an honest measurement of 3 thousandths. Now this has been machined, so I'd expect pretty darn near perfect. So let's say that we had measured 3s. Now the top and the middle show a little bit of out of round. The bottom has no out of round. It's perfectly round. But here's the point. If you're looking at top to bottom, we're going to draw some new lines here. If top to bottom, our measurement, as you'll remember, was 4.045. Okay? 4.045 was our measurement. And, you know, technically we could even make it 4.046, but, you know, in fact we will, because it was really an honest 6 thousandths under. And so we're going to go with 44. I'll erase up my finger here. We'll go with this number. We're going to judge it as harshly as we possibly can. We don't want to do it any favors. If 6 was the tightest, let's go ahead and use that. And then at the bottom, let's just say, this would be kind of backwards from typical, but at the bottom it's 3 thousandths under. Let's do this math really quick. If it's 4.050, but it's 3 thousandths under, that's going to be 4.047. So the bottom would be a 4.047. No problem. This is perfectly round. However, look at the difference between the top and the bottom. We got a bit of an issue here. The difference between the top and the bottom, quick math, 3 thousandths of an inch. There's taper on this cylinder because the difference between the top and the bottom. Now, a small note. If it was the difference between these two, we'd say there's only 2 thousandths taper. But again, we want to judge it as harshly as we can. So there's actually a bigger difference between these two. So let's go ahead and let's make that 3 thousandths taper. What that would look like in a cartoon way is if we had the cylinder here, it would actually taper down like this. Now that's totally exaggerated. And that's, you know, if it was like that, that'd be kind of backwards. It's typically the top that would be sort of opened up because that's where there's more thrust action when the compression's getting really high and everything. But the concept is still the same. So if you could use this tool effectively, you could go ahead and make a quick chart and go, okay, we're 4 under, we're 5 under, we're 4 over, and just basically use that baseline and do some quick math. This tool could really help you out. So hopefully that helps explain everything. Hopefully it helps you do what you're supposed to.